Again, Eureka with the names. Let's why do I gotta they're not good at titling things. They're just not good at titling things. We're gonna call this a geometric sequence. The actual title of this lesson should be Geometric Sequences. How to use them, where to use them. Yay! Let's do this. Alright. Not sure why all this stuff is here. Alright guys, so we've answered this question before. Right? We know how to do this. We would say that f of t is equal to, remember we had our principal times 1 plus our interest rate divided by the number of times compounded, right? And then we would raise that to 12 times 1, right? Because we're only going to do it in 1 year, right? So there's a 12 times 1 here. Whoops. 12 times plus. That's stupid. Sorry. That's not syntactically correct. So, if we wanted to calculate this, no problem, easy peasy. We put this into our calculator, we should get some sort of an answer. I'll go ahead and put it in our calculator. So we got 1,000 times 1 plus 0.03 divided by 12. So that gives us approximately $1,030, and we'll say 42 cents, right? If we're talking about money. But you have an interesting question here, and that is, what if we were to, instead of just depositing $1,000 and then letting it sit there for 12 months, what if we deposit $1,000 every month? Alright, so we have to look at what our interest rate is at this point. So this thing right here, this is what is interesting to us, and it turns out that that is, let's go ahead and calculate that real quick, 1 plus 0.03 divided by 12. This is our rate that our money increases by, right? So I'll just write that over here, that this 1 plus 0.03 divided by 12, it's our rate of increase, right? Every month, right? Because we would say that's our monthly increase, yeah? Because if we're going monthly, then this just becomes 1, right? It's not going to be 12 anymore, it's going to be 1. So that turns out to be equal to 1.0025. All right. So what's going to happen? It's going to compound still, right? So let's make a new thing. We'll call it P or T. Well, no, let's just call it P because I don't want to mess with it. Let's call this thing P. No, it's not yellow. Okay. All right, so you invest $1,000, right? This is the money I started out with. It doesn't really gain any interest because I just have it, right? After the first month, I get $1,000 times my rate of increase, right? So there's month 1. So I got my $1,000, and this here, the second term is the amount of money that gets added to my money for month 1, right? I put in $1,000, and then I added another $1,000 plus my rate of increase, right? This is going to keep going on. Son of a... Right? Month 1, it's like that's the first power. Month 2, and this is just going to keep going all the way until we get up to month, well, we're going how many months in 15 years? Let's divide it like a smart kid. Okay, 180, but we got to consider that this is the first term, right? So we're going to have 1,000 times 1 point. Sorry, I missed the 0. It's going to look something like this, right? As we go through, that's what, and we could add up 179 of those, or we could figure out a clever formula to use for this, which is what's about to come. Yay, let's do that, all right? Let's figure out a formula that would allow me to figure out what the sum of all these terms are. I don't want to add that up. That would be crazy. All right. So here we go. Crazy, 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 bro. Crazy. All right. So what we're dealing with is what's called the geometric series. We're going to have the sum of all the terms in a geometric sequence. So in other words, what we're doing is we have arithmetic series and geometric sequences and geometric sequences, right? Arithmetic, we're just constantly adding something, but it was a list of numbers, right? The difference between a sequence and a series is that instead of just having a list of numbers and trying to figure out how to get to the end number, right? What we're going to do is we're going to figure out the sum of all those numbers instead. Okay, so we're going to be adding them up. So in this case, we have a geometric sequence. Boom, right? And that's our example of it. We can see, and you can figure out, again, just like with a geometric sequence, with a series, if you needed to figure out what r was, it is still going to be a sub n divided by a sub n minus 1, right? So in this case, right, if we had 8 divided by 4, it equals 2/8. That checks out, right? A sub 1 is always the first term in our sequence. Alrighty, okay, moving on. So here's our formula that we could use for a geometric series. And geometric, the difference between a geometric series and an arithmetic series is the rate at which we're increasing. So, for instance, and you don't really have to know a lot about arithmetic series, but I'm going to go ahead and throw this formula out here for you. So we're going to use this formula. So the formula your book gives you is a little different, but the same formula. There was a brilliant mathematician by the name of Gauss. think his name was like Johann Friedrich something Gauss. Have him here. This guy. Johann Karl Friedrich Gauss. This guy is a good looking guy. So he's one of the greatest mathematicians of all time. And his although it's arguable that there are better ones. Johann, that's kind of a cool name. I'm not gonna lie.
Oh, guy named Johann.
Anyhow, his teacher, cool story about this guy. So he had a lot to do with matrix theory, matrices, which which is a lot of the math that's used in quantum physics, and quantum mechanics. So he kind of was a predecessor to all that stuff. As a small child, when they were just learning how to add in elementary school, of course this is a very long time ago, they would give them these little chalkboards, and that's how they would have to do their sums. So they had this little chalkboard, and the teacher wanted to kill some time, and she said, hey, add the numbers from 1 to 100, and tell me what the sum is from all the numbers from 1 to 100. And Gauss sat there and he thought about it for a minute, and then he came up with an answer. And so he was like, done. And the teacher freaked out on him. And what he did was he actually figured out this formula right here. He figured out this formula. He figured out that it was an arithmetic series, and then he wound up plugging that in there. So I mean, if we were to look at it, what is that? So what we're looking at is S sub 100, and that's going to be 100 times because it's the 100th term, right? We're just adding up, and you have 1 plus 100 divided by 2. I'm not sure how he just got that out.
How old is this kid?
He must have been in like 3rd grade.
What the heck?
He's one of the smartest human beings alive.
3rd grade?
Yeah.
Oh,
People that discover new mathematics, they're not like normal people.
I saw this kid online. Like, he's like 4 and he's climbing up to like billions. I'm gonna discover the
So it turns out that the sum is. So hey, if you can give it this memory, and someone asks you randomly to sum something, you could look really smart. They'll be like, whoa, you're the smartest person ever. And you'll be like, no, yeah. Although I have a tendency to think that Archimedes is the smartest of the best mathematician ever. Huh? Okay. So either way, both of these formulas that I just showed you will be given. Actually, the geometric series formula is on your part formula sheet. So if you're asked a question about the sum part, it's going to be given to you. So hey, let's go ahead and put this thing into use. If I wanted to find the sum of the first 11 terms of this thing, essentially what I'm being asked for is, what is S sub 11? And I could go 3 times 1 minus 1.5 to the 11th power divided by 1 minus, not negative 1. 1 minus 1.5. We can put that into our handy dandy calculators. I get approximately 512.985. Boom. And we just put that on our calculator all at once, right? And it shall work. Not this one. The arithmetic series, which is just, so for an arithmetic series, you're just counting, right? It's more of a countable. You think we have been able to figure it out? No. I would have just started adding fractions. I would have broken it into chunks of 20. Added 20 numbers, get the number on the side, add 20 numbers, get the number on the side, and then add those 5 numbers. That would have been fine. Okay. If we have some time, I'll derive that formula for you. Right, and the way that we would do this derivation would be that. And I guess I should back up a little bit. Sorry, I missed something. Where did I put this? Here. Sorry guys, I forgot to add something to this. These are in the form, so check this out, okay? These are in the form. So it's a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus a sub 1 r to the third plus, and we keep going all the way up to a sub 1 to the r times r to the n minus 1. Okay? Yeah. You can see they're always going to be in that form. And then possibly at the end, if we have some time, I can show you how you get the formula for that. I'll have to follow some instructions. It's an interesting derivation. It is some high level mathematics, so we'll see if we have some time to do it. All right, sorry I forgot about that. Here we go. So okay, again, I don't think we need to do another one of these, right? Plug the numbers in. Good. Awesome. Hey, but this is a little more interesting.
Oh yeah.
Okay. All right. Hey, firstly, so what do we need to do? We need to figure out what is a sub 1. Well, that's easy. It's 3. What is r? Remember, I can find that constant rate by dividing the term by its previous term, right? Any term by its previous term. So I could say, 6 divided by 3, right? That's this one and that one, and that's 2. Fantastic. And then I need to know what n is, right? Well, I can count them. 1, 2, 3, 4, 5, 6, 7. So n is 7. So then I go ahead and plug it into my handy dandy formula. So S sub 7 is equal to 3 times 1 minus r to the 7th power divided by 1 minus R, which is gonna turn out to be something. Okay. I like that. A nice round number, 381. That's the sum. How about this one? So again, a sub 1 is 40. R is equal to 1.005. And it's 11. Squirrels? So a sub 11 is equal to 40 times 1 minus 1.005 to the 11th power divided by 1 minus 1.005. Let's put that into our handy dandy calculators. 40 times 1 minus 1.005. Because as we're going through this, I recommend performing these calculations just to make sure that you're doing it right. And it's approximately. Whoa, 493. Oh, I'm so silly. What a dummy. My God. That is supposed to be 12 because, check it out. That's the first term, right? So 1, 2, 3, 4, all the way up to 11. But we're counting this one, right? This is n minus 1, right? So it should be 12 minus 1, which means that n is 12. Sorry about that. I don't know, we're shooting. Do you love me? I said no. Okay. Sorry, there it is. So, if we're going to describe a situation that would lead up to the sum, the book has some very boring stuff like, hey, what if you invested $40 a month into an account that gets 5% interest every year, right? Is it 5% or 0.05? Let's see. 1 plus. Yeah, it would be 0.5% interest, right?
5%.
No, it's 0.05%. My bad. But I said something cooler. Last year, I don't know when this came from. I looked at my notes from last year, and it said, "Hey, you add 40 manatees." Did I see Mantiques? It was a Mantic one. Yeah.
For bank accounts, does your interest rate get lower the one
Okay, here we go. Let's do a good old-fashioned word problem. Okay, so what does this look like? I have S of x going to be 100 plus 100 times, what's my growth rate? It's going to be, let's see, annual interest rate, so 1 plus 0.03, right? If it's annual. I'm just adding that. And that's going to go all the way up to 12 months. So n minus 1, so 11, right? That's what it's going to go there. Okay, so if I want to figure out what that sum is, I'm looking at S sub 11, which is going to be 100 A sub 1 times 1 minus R, which is that, right? So 1.03 to the 11th power. Stupid. What do I keep doing that? We want S sub 12. I keep doing it. I'm sorry for making a mistake. So 12 over 1 minus 1.03, which turns out to be, if I put that in my calculator, approximately 1,379.56. If you put that in your calculator. All right. Hey. Sometimes we're missing some stuff. We may have to solve. So that might be the case. You might be given a problem where you're missing some stuff. So that formula right there, this guy right here, that's what we're going to use to find any missing information that we might have. Ready? Let's go ahead and do it.